All right, I'll stay here and then we'll work around it in a little bit. So, apologetics or explanations. We're explaining evidences. Sometimes apologetics is called evidences. We're explaining the evidences for our faith in what the Bible says to be the truth, our faith in God, our faith in Jesus, our faith in the Bible itself. These are all things for which we make explanations. Yes, this is why we believe this. What language, by the way, tells the Genesis story? Chinese language tells the Genesis story. When you look at the characters, you see very strong evidence for their knowledge of the flood and 8 people being saved in a boat and sacrifice and blood and lambs and Satan and deception and temptation with regard to 2 trees. So many elements of the book of Genesis are in the Chinese characters. Shaddai is the name, as we would pronounce it, that the Hebrews, that Abraham, as a matter of fact, knew God as. But do you remember the name that the Chinese had for their one God in the beginning? Shangdi. All right, so very similar. Shangdi, Shaddai. Very likely, at least in my thinking, that Chinese God was the same God Abram worshiped. How many links in the evolutionary chain for humanity did we take a look at? And what can you tell me about some of those? How many of them actually existed as links in the evolutionary chain? There aren't really any. A lot of them are put up there. Some of them come from one bone. They later find out that one bone, that tooth, was a tooth of a pig. Those kinds of things take place. One, the Piltdown Man was actually a hoax. It wasn't a human skeleton at all, but something put together, manufactured to fool people. And it did, in fact, fool the experts for a number of years until they discovered it was a hoax. So we've got that. This morning we're going to be looking at strata. This lesson is entitled "The Rocks Cry Out." That's taken from Jesus' entry into Jerusalem when he was told to silence those who were calling out as him to be the deliverer. And he said, if these keep quiet, even the rocks will cry out. And in a very poetic way, the rocks all over the world, the sedimentary layers of rock, are crying out that what the Bible says, especially about the great flood of Noah, is the absolute truth. A lot of people think of it as myth and fiction, but it's in fact reality, and we are looking at evidences for that flood. Stratigraphy is the study of layered materials, strata, that were deposited over time. That's from the encyclopedia.com. Is it on? Are we better with sound? Not yet, not yet. Okay. And you can see I got a picture here. I found this one because it's very pronounced layers. Each one of those layers was laid down by itself, but what actually happened, I believe, is the waters of the flood had all of this stuff in it, and each different kind of grain of dirt, of sand, whatever it was, fell to the bottom according to weight and density and just layered up naturally. You can do this experiment that I have done several times. Take a large jar, like a jar you'd make tea in, and put different kinds of soil in it, and fill the jar maybe a fifth or a fourth, a quarter of the way with the dirt, and then put water in the rest, and then you shake it up. And if you've got different kinds of soil in there with different weights and densities, it will layer itself out very quickly, actually in a matter of seconds, and settle to the bottom. And you'll look at it and you'll go, wow, look at all those layers. And you shake it up again and it will do exactly the same thing every time. It's called hydrology. It's just physics. It's the way the world works. As a matter of fact, the last time I did that, I left that jar, put it in my study so people could come in and see it. They said, what's that? And I thought, oh, that's a jar. I did this to show how water separates different kinds of soils out and makes layers. And in less than 2 years, guess what happened to that dirt in the bottom? It turned to stone with No more time and weight that it had, it turned to stone. So it was very difficult to get. As a matter of fact, that jar doesn't exist anymore. So I got another jar, and and that's what you can do on your own sometime to do a simple experiment at home to see how that works. Johnny?
Lucky thing an archaeologist didn't find that. Is that in your garage?
Yeah, good thing an archaeologist didn't find that in my study. Yeah. Who knows what he would have said about that. But this is what we're looking at this morning. How many of you have seen, you just notice it everywhere you go, not as much in Oklahoma because Oklahoma is more flat, but when you go into places, parts of Oklahoma where it's not flat and they've carved through a hillside to make a road, you'll see it more out west. You'll see it especially a lot down in the southeast part of the state. You'll see these layers of strata alongside the highway. They're everywhere. They're prolific. This is near my home in West Virginia. And if you want to build something in West Virginia, this is about what you have to do. You have to carve a mountain away to make it a flat place to build any kind of a business. So we've got kind of a mini strip mall down there that they put in, but they had to carve a mountain away. And when you carve that mountain away, you see all these layers. The vertical lines are where they drilled into this to break the rock away. But those horizontal lines are different layers of strata. And I believe all that stuff was laid down during Noah's flood. All this swirling mass of dirt and rock and conglomeration of whatever was laid down in the days of the flood. And it settled, became stone, and that became the Appalachian Mountains. And this stuff is everywhere, all over the surface of the earth. This is the Boxy Syncline. This is also in West Virginia. We just happen to have some bent strata. And what do you notice about that strata in the corners where it's bent up? Not the flat part, but where it bends up. Do you see any cracks? Do you see any breakage? If it were stone when it was bent, it would have broken up into small pieces. What this shows us is that when this strata was bent like this, it was still soft. It didn't have time to form into rock. And so this happened, I believe, all during the flood. The strata was laid down layer by the flood waters, and before that stuff could harden into stone, there was some kind of a tectonic event, a volcanic upheaval, maybe whatever it might have been, that pushed this strata in different ways. And you'll find this stuff all over the earth as well, bent strata. It wasn't done with heat. If it was done with heat, you would find where some of that stone had crystallized by virtue of the heat. And it's not broken, so it wasn't pushed and bent while it was stone. It was pushed and bent while it was still wet and pliable and soft, just like when you take modeling clay. Your kids buy Play-Doh and you mess with that stuff while it's soft. But modeling clay, you set it off to the side and you leave it long enough, what's it going to do? It's going to harden. It's going to turn stiff, and you try to mold it, it'll break. So this was molded. This was shaped while it was still wet. Had to be some kind of a huge catastrophic event that created the Boxy Syncline as well as others. This is one of our own bent stratas right here at Beaver's Bend, Oklahoma. I didn't know beavers could do that kind of stuff, but that beaver bent that. I don't know, it's called Beaver's Bend, and of course we've got bent stuff. Isn't that interesting? But that's right here in Oklahoma, out in the eastern part of the state. So if you want to see this, a couple hours, you can go witness it yourself. Take your camera, take a picture, and this is strata that's been bent, almost certainly bent while it was still wet, pliable. How'd those layers get there? Standard explanations. By the way, how many of you have been to the Grand Canyon and heard the rangers spiel on how that canyon was formed? I've been there, heard the explanation. What do they say formed the Grand Canyon? Colorado River formed the Grand Canyon. Just over millions of years, the flow of that river steadily carved that canyon down and down and down and down. That's what we are told. That's what we've been told. That's what I learned in high school, all growing up. There's an alternative explanation, though, and that is that this material was deposited rapidly over a single year during the flood of Noah's day. That's what the Bible tells us happened. Now, the Bible doesn't mention stratigraphy or strata. It just says there was a huge flood over all the surface of the earth. And from that, we figure out, we deduce that these layers of strata are from that flood. Here's my disclaimer. I'm not a geologist. I am, however, fully qualified to tell you what geologists say. Everything in this lesson is being presented to you partly because qualified geologists say it's all so, but mostly because God told us about the flood, and these are the things we would expect to find if there was a great flood. And that's the way you have to look at things. God said there was a flood. Well, if there was a great flood, what would we expect to find? We would expect to find waterborne strata all over the world. That's what we would expect to find. If the flood, the purpose of the flood was to destroy all life on the planet except for that which was in the ark, what else would we expect to find? Well, we'd expect to find fossils buried in those layers of strata, not deposited after the strata was created, but laid into the strata as the strata was being formed. These dead animals, dead trees, or living things at the time would have been deposited and turned to fossils. So we would expect to find all that, and that's exactly what we do find. So there's my disclaimer. By the way, common sense is one of the greatest blessings God gives humanity. And you can look at these things and you can tell, all right, something happened here. You don't have to be a geologist. Some things we need people who've studied it in more detail to explain, but other things you can look at and say, well, it had to be like that. And a lot of that is what we're doing. As the Holy Scriptures have been misrepresented or misinterpreted and misrepresented through the ages, so the messages of the stones has been misinterpreted. In other words, we've got the same evidence. It's all right there in the rocks. We're looking at it, and we interpret it one way. Somebody else looks at it and interprets it another way. We look at it and we say, well, that had to be laid down by the flood within the space of about a year. Somebody else says, well, no, those layers were laid down of millions of years for this layer, millions of years for that layer, thousands of years for that layer, however many years they might tell us. And that's how all those layers were put down. But there's a different story. And I've said this before, I'll say it again. Find a teaching in the Bible that is not countered by some human teaching or even a demonic teaching. Paul talked about doctrines of demons. And I wonder sometimes if teachings we think come from human beings have actually been planted in those human beings' minds by demons, because the forces of the spiritual world are still at work. And Paul said our battle is not against flesh and blood, but it's against spiritual entities. And so we are fighting that same battle today with these ideas coming up that interpret the things we see in the world with a very secular eye, a very worldly eye, a very godless eye. But we look at it and we say, well, God did that. Big difference in points of view. Strata is prolifically ubiquitous. Isn't that a fun word to say, ubiquitous? I first saw it on a billboard in Leavenworth, Kansas. And I said, I got to find a place for that word. And here it is. Here's the place for it. Strata's everywhere. It's down by the seashore. And look at all those layers. I mean, just layer after layer after layer right down there by the ocean. And there it is up in a high desert. There's some more in the mountains. Everywhere you go, if you're paying attention, if you look for it, you will see strata. You will see layers of earth laid down, and it had to be laid down by water. There had to be some kind of water involved to get these layers put down the way they were. Sedimentary rock is made from sediment. Any material that settles to the bottom of a liquid, any material deposited by water. And it doesn't have to be water, but that's primarily the basis for all of the sediment that settled. By the way, how many of you used to drink coffee made in a percolator? Or still do? All right, that's the best coffee I think you can find, unless you want to go to some really fancy stuff. But generally speaking, that's how I understood coffee to be all my growing up years, because Mom used a percolator. And if you drink the last little bit of the coffee, what are you going to find at the bottom of the cup? Sediments, coffee sediments. That's all we're talking about. It's just stuff that's in the liquid that goes to the bottom. That's what sediment does. It's heavier than the water, so it goes to the bottom. You put more sediment in, it's going to go, and if you stir it up, the heaviest sediment is going to go to the bottom, way bottom, and then the lighter sediment will be stacked above that accordingly. So that's what we're talking about when we're talking about sediment and sedimentary rock and sedimentary layers. Rock made of sediment such as clastic rock, made of fragments of other rock transported from its source and deposited in water. So it's clastic rocks made of rock. It sounds kind of silly, but you think about it, it makes sense. And then there's rock salt or gypsum that's formed by precipitation from a solution. What's precipitation? Well, that's something that's falling from the sky. We think of it as rain, but there's all kinds of precip. You put dirt molecules, sand molecules in water in a solution. As they fall out of that solution, that's precipitate. They're precipitating to the bottom. Gypsum is a big deal in Oklahoma. We've got a place where gypsum is taken from the earth and used in construction. What's gypsum used in, by the way? Anybody know? Sheetrock. It's all around us. It's all around us. And then there's rock made from organisms, shells, coral, algae, fecal debris, also precipitating from water, limestone. So you get all of this stuff in one thing of water, however small or large you want it to be, and you stir that water up, it's going to precipitate based on its weight and its density. And this is what we were talking about earlier with the jar. It will always sink to the bottom in the same order, in the same fashion, and make the same layers every time. How did all this strata get there? Well, the fountains of the great deep were opened up. If you look at Genesis chapter 7 and verse 11, God says this is how he made the flood happen. In the 600th year of Noah's life, in the second month, on the 17th day of the month, on the same day, all the fountains of the great deep burst open, and the floodgates of the sky were opened. The rain fell upon the earth for 40 days and 40 nights. So the floodgates, or the fountains of the deep, I used to think fountains of the deep, that must be water, but it could also be lava. And in a little bit in this presentation, good Lord willing, we'll see the undersea volcanoes that exist all over the planet below the water, of course, and those are also fountains of the great deep. So the fountains of the sky, I'm sorry?
I was say which would have put a lot of acidic stuff up there too to help break down. I mean, if you think about the caverns, the caves, you're just talking about Grand Canyon. If water's coming down, instead of acidic, breaking down other sediment that was already formally formed.
Right.
In the first place.
And we'll see one slide that shows us that there was a lot of volcanic ash that was dropped in layers, and there are sedimentary layers of volcanic ash. And volcanic ash is the catalyst that you need, as a matter of fact, to form coal. Volcanic ash is the perfect catalyst, because you can't form coal without some kind of a catalyst, but if you've got volcanic ash, it's the perfect catalyst. And where do we find coal? Just a few places. Like all over the surface of the planet, well, surface, but within the layers of sediment, you find coal. And it takes about, if I remember right, well, we're coming to the slide, but it takes about 10 to 20 feet of organic material to form a foot of coal. So it compresses and forms coal. We would call coal a rock or a stone, but it's all over in the earth. And it forms with a catalyst, and the catalyst that could have been provided was volcanic ash. So I'm glad you brought that up, Dave. Fountains of the great deep were open, floodgates of the sky were open, rain fell for 40 days and nights, and water prevailed 15 cubits above the highest mountain. Now, that would have been, of course, the highest mountain that was then, but with all of that tectonic activity, we have no way of knowing how high the highest mountain was, but how high is 15 cubits? We're talking about, generally speaking, an 18-inch cubit, so that's a lot of water to cover that deep over the highest mountain. Everything else was way down below that, I'm sure.
And I mean, if you, I'm not gonna interrupt you, but you think about the weight of water, and think about tectonic activity from when it starts flooding, running off the brine.
Right.
I don't know, that book up my mind a lot.
Well, the forces at work here are unbelievably powerful. I don't know that the human mind could fathom how strong that stuff. Have you ever been in water that overpowered you? It doesn't take much water. What's the thing in Oklahoma when it starts to rain and we get some floods? What do they start putting on TV? Turn around, don't drown, and then they show you the video of a truck, because if you're in a truck, you're invincible. You drive into that water, and the water gets up it's not much water, and the truck starts floating and going away. It's gone. And that's just with a tiny little flood like we might have around here locally. We're talking about a flood that covered the world. Tsunamis. What do we learn from tsunamis? Oh man, you want to get way inland, or a tsunami will it will destroy you. And one of the things, it was like a duh factor when I read it. It said that the danger of the tsunami is not the water, but it's all the stuff that's in the water, which would help describe the circumstances and explain why we don't often find huge dinosaurs intact. We find parts. There's a leg here, there's a skull over there. Well, these forces were so great that they probably tore apart everything that was in them, and if something dies and it's in the water for a few months, just swirling back and forth, there's all kinds of ways that things could have been ripped apart, destroyed, torn up. All that debris, all that force, all that commotion, it had to be horrific. And the whole point of the flood was, God said, I'm going to wipe this planet clean. Which is why when Peter comes along, he says of Noah that he was saved by the waters. And I used to think, that's crazy. He was saved by the ark, wasn't he? But from God's perspective, the water wasn't the danger. What was the danger from God's perspective? It was the spiritual depravity of man. It was the sin. And so when Peter talks about that in 1 Peter 3:20 and 21, he talks about Noah being saved through the water, by the water in some translations, and that makes perfect sense. By the way, when Peter does that, what is he saying about the flood? He's saying the flood happened. When Jesus mentions Noah, what is Jesus saying about Noah? He was a real guy. The flood happened. When he uses the flood as an example for the final coming, Jesus is saying, yes, the flood was a real thing. It's history. It's not myth or legend. All of these things are corroborated by Jesus and the apostles. So there is that to consider as well. So 15 cubits above the highest mountain, that's from Genesis chapter 7 and verse 20, and the waters prevailed for 150 days before receding. And wouldn't you like to have been there? Well, I don't know, maybe not. But wouldn't you like to see a video of what it was like all over the surface of the earth? And the fountains of the great deep having broken up, and all the stuff that would have been in the water, and the rain coming down for 40 days and 40 nights. And I'm sure that water was not just a still, calm sea, just raised up, drowned everything, and then went back down. It had to be doing a lot of crazy stuff, and the evidence for that is in the sediments as well. Tops of the mountains were visible after 10 months. So the water began to recede, and that's when the tops of the mountains became visible. All right, undersea volcanoes. There are literally thousands of them yet today. And here is a map of the Atlantic Ocean. As you can see, there's the African continent on one side and South America and North America on the other. You can see that red line going up the middle, that squiggly red line. Those are all volcanoes. And you go a little farther over in the top right, and you see all that red up there, those are volcanoes over in the area of the eastern Mediterranean. And then you come way back over to the opposite side of the globe. You see red down along the Gulf of America, and then down the western side of the continent of South America. Well, that's the view from here, but if you just look at it from the Pacific, there's South America there, down in the bottom right, and that line of volcanoes goes all the way up South America, through North America, across the Bering Straits to Asia, right down the eastern coast of Asia, down through Australia and New Zealand. This is called the Ring of Fire. These are all underwater volcanoes. So when God says the fountains of the great deep burst open, this is almost certainly what he used as the fountains of the great deep, because all of these volcanoes to go off at once. Now somebody might say, oh, how could God do that? Listen, when you read Genesis 1:1, what does it say? In the beginning, God created the heavens and the earth. If we accept that, and it makes perfect sense, because when you look at the universe, there is no physical explanation for the universe to exist. There's no reason for it. And if it was purely physical in nature, there should be some physical reason that we could discover or determine. If life was purely physical in its nature, there should be some aspect of it that we could, through research, figure out. But we can't figure out life. We can't figure out how the universe exists. People will tell you, oh yeah, we know, 4.3 billion years ago, something that shouldn't have existed exploded, and we got yeah, right. That's not even a plausible theory as theories are defined scientifically. That's conjecture. As Paul would term it, I believe in Romans chapter 1, it is foolish speculation. We talked about that a week or two back. But here's evidence for the flood. Who knew about these volcanoes until they were discovered in recent centuries? They wouldn't have known about it, I'm sure, in Noah's day, except for the fact that they exploded and covered the earth in water and all kinds of other things, volcanically speaking. There's my home state of West Virginia. And that light blue, can you see the blue? Yeah, you can see that. That's where coal is found, just in West Virginia. That coal seam goes on down into Kentucky. There's coal, by the way, in Oklahoma. It's not a widely known fact, but how many of you knew coal mines exist in Oklahoma? All right. Yeah, they brought foreign laborers in here to work those coal mines many years ago. So there's coal everywhere you look in the world. And what is coal? Coal is sediment. I remember being in high school and reading the textbook that taught me coal is formed from ancient peat bogs that settled and hardened into coal. That's how we are told to understand the existence of coal. But here's the problem with that. There's a few problems. Peat bogs are full of the roots of plants, but coal is almost entirely made of tree bark. Peat bogs are relatively small in size, but many coal seams go on for miles. That one that covers the state of West Virginia, and it doesn't stop at the border, by the way. They mine a lot of coal up in Pennsylvania. By the way, that line right there, what's that line? Anybody know what that flat line is going east and west to the top of West Virginia? That is the Mason-Dixon line. How many of you have heard of the Mason-Dixon line? All right, yeah, we've heard of the Mason-Dixon line. Well, there it is. What did you learn in Bible class this morning? We learned where the Mason-Dixon line was. It's right on top of West Virginia. It separates West Virginia from the Yankees. That's how everybody used to look at it. Said everything south of the Mason-Dixon line was Dixie. So anyway, there's your little bit of geographical trivia for this morning. But I wanted to go back to this to let you think about the idea that coal seam is running right up through the end of West Virginia, north into Pennsylvania, and right on down south into Kentucky. And it's everywhere. Coal is all over the place. And this is how it forms, not by peat bogs, but by sedimentary life, organic life that became sediments that settled to the bottom and was compressed together. Both the top and bottom of peat bogs are irregular, but coal seams have perfectly flat bottoms and tops, which makes sense. In the Great Flood, all the dirt sediment would have gone to the bottom, and the organic material, which would have been lighter than the dirt, would have later settled on top of the dirt and sand. And so there would be a flat surface for all that organic material to settle on, and then as it settled out, the other materials settled on top of them, and it was buried. And that coal, a lot of it's buried deep within the earth. Talk about that, Lord willing, here a little bit too. So both the top and bottom of peat bogs are irregular, but coal seams have perfectly flat bottoms and tops. Peat bogs do not contain marine fossils, but coal beds do. So Semper Fi. Oh, different kind of marine. Peat bogs do not contain the bodies of animals, the fossils of animals that were seagoing, but coal beds do contain those bodies. Bituminous ubiquity. I got to use it again. Coal is formed from organic sediment and is everywhere on the planet. It takes 10 to 20 feet of organic material to make a layer of coal 1 foot thick. And the Powder River coal seam in Wyoming is 200 feet thick. So how much organic material would it have taken to form a 200-foot thick coal seam if it takes 10 to 20 feet of organic material to make 1 foot of coal? And think about that. When God is scrubbing off, so to speak, the surface of the earth, cleaning it of all living things because of the evil that was there, he would have also scrubbed off all of the plants, all of the trees, all the grasses, everything that existed, everything that lived would have been wiped clean, as if God were wiping the slate clean to start over with Noah and his family. And so all of that organic material would have been the basis for today's coal. It was all buried and buried deeply and buried quickly. 75 miles is how far this one particular coal seam goes. You don't find too many 75-mile long peat bogs, do you? But there you have it. Russia has a mine 3,000 feet deep. In other words, you have to go down over half a mile to get to that coal. How did all of that organic material, because that's what coal is, how did it all get buried half a mile deep in the earth? That's a question. Of course, Russia's like Texas. They always have to be bigger and deeper than everybody else. But they've got one that's 3,000 feet deep. We can make coal. Researchers have made coal in less than 4 weeks. Have you ever been taught in school how long it takes to make coal? Oh, millions of years. Well, researchers can make it in 4 weeks. When I say we, you understand I'm not talking about myself. I wasn't there, but human beings can do it. You can make coal only if there is a catalyst, that's a plant material, and pressure and heat. It's all got to be there. Volcanic ash provides the perfect chemical elements for such a catalyst, which is what you were talking about earlier, Dave, the volcanic ash being in the air, mixed probably with nearly everything. Here's Ecuador. Isn't that interesting that we have these layers of ash that are laid down? And that top layer, what do you notice about it? It's an arc. It's bent. It's not laid down perfectly flat. The layers are perfectly even, but all of them together are bent. And that had to happen while it was still soft. So that's quite a bit of volcanic ash in Ecuador. And it didn't take a whole lot of it to serve as a catalyst to make coal, and it was probably everywhere else as well. So, staircase. You ever seen a staircase that goes for 150 miles and it's 2 miles high? Isn't that beautiful? The irony is that came from the flood. This is the result of flood runoff. All of those layers that you see are sediments, things that were in the waters of the flood that settled out of those waters to the bottom and became stone. All those different colors just tell us there were different types and densities of rock and stone and materials that were dropped to the bottom of the water. So this is the Grand Staircase in Arizona. You can drive for a few hours or several hours, and you can see this for yourself. It's over in one of our neighboring states. And this is a diagram of the Grand Staircase. We've got 2 miles worth of waterborne sediment. In other words, that's how high it is. The first layer that's on the bottom is waterborne sediment, and then the next layers gradually piled on top of that until you had a 2-mile thick set of sediments. And it goes on for 150 miles. The scale is amazing. Now, as you're looking across, you got to ask the question, if you're thinking about it, where is all the sediment that was removed to make the staircase? Because when you look across and you see the sedimentary layers on the other side, you know, well, there had to be sediment between whoever's taking that picture and where those cliffs are that show us the sedimentary layers. There had to be material in between the photographer and the Grand Staircase, as it's now called. And when you look on top of the Grand Staircase, you find smaller hills that are also sedimentary. When God said he covered the earth to a depth of 15 cubits, he was being serious. There's an aerial view of the Grand Canyon. I've seen it from the air. I lived back in the day when if you flew over it, the pilot would get on the intercom and say, hey, everybody look out to your left side of the airplane. You'll see the Grand Canyon down there, and tell you stuff like that. I don't think they do that anymore. I traveled back when it was fun to get on an airplane. Now it's not the same. And I traveled back when people dressed up because it was special to fly on an airplane. And airplane food was good. Everything has changed. Now they throw peanuts at you if you're lucky. How did I get off on that? Well, here's an aerial view of the Grand Canyon. I guess that's how I got off on that. And there it is. Big ditch in the ground. Great big ditch. Here's another view of a Grand Canyon. And I'm being a little facetious here, but I wanted to make a point. What's that look like to you? I mean, it looks basically the same as that. But the scale is much different because this is just a picture of a farmer's field where they've had a little bit of rain, and that's what's happened in his field. By the way, do you see those rocks in that erosion? If the volume of the water is high enough, it'll pick up rocks like that and move them forward, and those rocks will help increase the erosion that's taking place. And so you could imagine how a large flow of water picking up debris and carrying it downstream on the way would create even more erosion. And it wouldn't take long to form out a big ditch. How long could this, if you were a farmer and had a field like this, how long would it take this to form? Not that long. Doesn't take long. How many of you have yards with things like this happening and you're going, more grass over? It's erosion, that's all that is. Here's Mount St. Helens, and in the foreground is the canyon. This was back in 1980 that this happened. Got the North Fork of the Toutle River, and on May 18th, 1980, 600 feet of volcanic deposition filled the riverbed. Now, that riverbed wasn't there. The picture we have here, the riverbed was very different before the explosion. That whole riverbed was covered over by 600 feet of deposition. The picture we're looking at here is after that riverbed was then carved out again on March 19th in 1982. by a mud flow that was moving at 90 miles an hour, and it was carved out in a matter of hours. So we're back to the ranger standing at the edge of the Grand Canyon telling us that little bitty Colorado River that you can barely see down there is what carved out this entire canyon over millions of years. But you go to Mount St. Helens, and after this volcanic deposition had been there for less than 2 years, or about 2 years, a little less than 2 years, a mud flow came through and carved out a canyon, and it was just a matter of hours that it took for it to happen. So we got to wrap this up pretty quick. Rapid sedimentation now argues for rapid sedimentation in the past. 600 feet of volcanic sediment put down in a matter of hours, and then rapid erosion now argues for rapid erosion in the past. In a matter of hours, those layers of sediment were carved through to create a canyon. I think it's 1/40th the size of the Grand Canyon. And Lord willing, we'll come back and we'll wrap this up next week. These are polished straight trees, tree trunks that go through multiple layers of strata. So if those strata layers were laid down over millions of years, there wouldn't be a tree trunk there. It would have rotted away a long time ago. And these are all over the place. Well, we're basically at the end of the presentation here. But these are things that we can just look at. And you, with common sense, can look at these things and say, wow, how'd that happen? There had to be a big flood. There had to be a big cataclysmic flood, not a little local affair, but a huge affair. And why is there coal buried so deep in the earth? We didn't even talk about oil. What's oil? My favorite gas company is Sinclair, and the reason they're my favorite is because they have a dinosaur. Why do they have a dinosaur? Because that's the thinking on all that organic material, that it was all the stuff that lived in the past was buried, and it turned into oil underground. And as it was decomposing, it also released gas. And that natural gas, what do we call coal and oil and natural gas? How do we term that? Fossil fuels. And it's deep in the earth, and it's all over the earth. It's like the rocks are crying out to us. What God said is true. There's our class. Ring another bell if you want to. I don't care.